Hey guys, as you all know, starting today, we're going to learn OSINT from the absolute basics all the way to advanced techniques. So let's get started. First, let's understand what OSINT actually is. OSINT stands for Open Source Intelligence. It is a huge field within cybersecurity that involves collecting, analyzing, and connecting information from publicly available sources. There are many different areas within OSINT, such as user investigations, GEOINT, search engine dorking, social media intelligence, digital footprint analysis, and much more. Throughout this series, we're going to cover these topics step by step, starting from the fundamentals and gradually moving toward more advanced concepts. But before we start investigating anything, we need to prepare our own system for OSINT. As you will learn throughout this series, privacy is one of the most important principles in OSINT. Think about it. If your own device is leaking information about you, your investigation can potentially expose your identity or your real-world digital footprint. And because
browser for a large part of our OSINT work, the first thing we need to do is choose the right browser. For this series, we're going to use Firefox. Why Firefox? Because Firefox is open source, highly customizable, and provides a lot of privacy-related configuration options. We can customize various browser features related to fingerprinting, tracking, cookies, permissions, and other privacy settings. Even seemingly small pieces of browser information can sometimes contribute to browser fingerprinting. That's why, when you're doing privacy-focused research, it's important to understand what information your browser is exposing. So let's start configuring our browser. Preparing our system.
Before we begin configuring Firefox, let's install a basic security tool that can help us scan files for malware. Open your terminal and run sudo apt update. This updates your system's package information so that your package manager knows about the latest available software versions. Now install ClamAV. Sudo apt install ClamAV. ClamAV is an open-source antivirus engine that can be used to scan files and directories for known malware and suspicious content. Once it's installed, you can scan a specific file using ClamScan filepath. For example, if you have a file called example.pdf in your current directory, you could run clamscan example.pdf. ClamAV is not a replacement for a complete security strategy, but it is a useful tool to have on a Linux-based OST workstation, especially when you're downloading or analyzing files from sources you don't completely trust. And with that, our basic system preparation is complete. Now let's move on to hardening and configuring Firefox for privacy-focused OST work. ClamAV is not a replacement for a complete security strategy, but it is a useful tool to have on a Linux-based OST workstation, especially when you're downloading or analyzing files from sources you don't completely trust. And with that, our basic system preparation is complete. Now let's move on to hardening and configuring Firefox for privacy-focused OST work.
Installing privacy extensions. Next, we're going to install a few browser extensions that can help improve our privacy and security. The reason we're using extensions is that they can help us block unwanted trackers, third-party scripts, malicious advertisements, and other browser-based threats before they interact with our browser. Open the Firefox menu by clicking the hamburger menu in the top right corner, then go to Extensions and Themes. Now, let's install our first extension. Search for uBlock Origin. uBlock Origin is a powerful open-source content blocker that can block advertisements, trackers, and many unwanted network requests. It's one of the most useful extensions for a privacy-focused browser. Install it and add it to Firefox. Next, search for Privacy Badger. Privacy Badger is designed to detect and block certain third-party trackers that attempt to follow you across different websites. Install the extension and enable it. And finally, we're going to install NoScript. NoScript gives you much more control over which websites are allowed to execute JavaScript and other active content in your browser. This can be particularly useful from a security perspective because a compromised or malicious website may try to execute unwanted scripts in your browser. However, keep in mind that NoScript can also break parts of legitimate websites, so you'll sometimes need to manually allow scripts for websites you trust. Configuring Firefox privacy settings. Now let's configure some of Firefox's built-in privacy settings. Open the Firefox menu from the top right corner and click Settings. Then go to Privacy and Security. Scroll through the available options and review the Firefox Data Collection and Use section. Here, you can disable the optional telemetry and data sharing features that you don't want to participate in. This reduces the amount of optional technical and usage data that Firefox sends to Mozilla. Opening Firefox Advanced Configuration. Now we're going to configure some more advanced Firefox settings. In the Firefox address bar, type about:config and press Enter. Firefox will display a warning because these settings can affect how the browser works. Read the warning and proceed only if you understand that changing advanced preferences can cause unexpected behavior. Now, in the search bar, type privacy.trackingprotection.enabled. Find this preference and set it to True. This enables Firefox's built-in tracking protection, which can help block known tracking resources and scripts. And that's our first advanced Firefox privacy setting. We'll continue configuring the browser step by step so that we have a more privacy-focused environment for our OSINT investigations. More Firefox privacy settings. Next, search for geo.enabled. Set it to False. This disables Firefox's geolocation API, which means websites won't be able to use Firefox's built-in location API to request your device's location. Next, search for browser.safebrowsing.phishing.enabled. Set this to False. This disables Firefox's built-in phishing protection. However, there is an important trade-off here. Disabling this setting reduces your protection against known phishing and malicious websites. So, if you disable it for privacy reasons, you should be extra careful about the websites you visit. Next, search for dom.event.clipboardevents.enabled. Set it to False. This limits websites' ability to receive clipboard-related events when you're copying or pasting content. Keep in mind that this doesn't make your clipboard completely invisible to every possible website mechanism. It mainly changes how Firefox exposes clipboard events to web pages. Now search for media.navigator.enabled. Set it to False. This prevents websites from using Firefox's media device enumeration APIs to discover information about available microphones and cameras. Next, search for dom.battery.enabled. Set it to False. This disables Firefox's battery status API. Why does this matter? Browser fingerprinting can combine many different pieces of information about your device and browser. Battery information can be one potential data point, so disabling the battery status API can remove that particular source of information. The most important part, WebRTC. Now, let's talk about WebRTC. WebRTC is a browser technology that allows websites to establish real-time audio and video communication. It's what makes features such as browser-based video calls and voice communication possible. But there's an important privacy consideration here. Depending on your browser, VPN configuration, and WebRTC implementation, WebRTC can potentially expose network information that may reveal an IP address outside the VPN tunnel. So if you're using a VPN and want to minimize WebRTC-related exposure, you can disable WebRTC's peer connection functionality. Search for media.peerconnection.enabled. Set it to False. Then configure the following. media.peerconnection.turn.disable. Set it to True. Next, media.peerconnection.
media.use_document.ice servers. Set it to false. And finally, media.pureconnection.video.enabled. Set it to false. Keep in mind that disabling WebRTC can break or limit browser-based video calls, voice calls, and other real-time communication features. That's it for this episode. And with that, our basic privacy-focused OSINT browser setup is around 75% complete. We're not going to configure everything at once. In the upcoming episodes, we'll continue adding and adjusting settings as we actually need them for different OSINT techniques and investigations. This way, you'll understand not just what we're changing, but also why we're changing it. If you didn't understand something in this episode, feel free to leave your question in the comments or message me on Telegram. I'll see you in the next episode, where we'll continue building our OSINT environment.